So now we'll move further. We know y of x is equals to c1 y1 plus c2 y2. Y of x is equals to c cos 5t plus c2 sin 5t. These are the values of y1 and y2 we find out earlier. So this is the general solution. General solution of non-homogeneous OD. For particular solution, we will apply basic rule. So basic rule for particular solution. Then m of x is 25 sin t. Y of p is equals to k omega st plus m sin t. Now we'll differentiate with respect to t, yp. We'll differentiate yp. So yp dash, it will come out to be k sin t plus m cos t. This is cos, k cos t plus m sin t. So k sin t, that will come out to be negative, cos negative, m cos t sin differentiation. And yp double dash, it will come out to be minus k cos t minus m sin t. We'll put the value of y p double dash and p dash in equation 1. So we'll put value of yp double dash and yp dash. So it will come out to be minus k cos t minus m sin t plus 25 k cos t plus m sin t is equals to 24 sin t minus k cos t. Okay, sorry, it's not visible. So k cos t minus m sin t plus 25 k cos t plus m sin t is equals to 24 sin t minus k cos t minus m sin t plus 25 k cos t plus 25 here minus k cos t. It is carrying out. This 25 got multiply here, k cos t plus 25 m sin t is equals to 24 sin t. And now here is no cos term, so k will come out to be 0 because there is no cos term. And m, we can find it out, m come out to be 1. 24 m sin t is equals to 24 sin t, so m is 1. We'll find out. Now we'll put the value of k and p. Put value of k and m in y of p. Now yp will become 0 cos t plus 1 sin t. So yp will come out to be sin t. So this is one of the result, and we'll write it as equation 3. So now we know the value of yp. If we find out, now yt we as know is equals to yh plus yp. So yt will write yh, we find out 1 cos 1 c1 cos 5t plus c2 sin 5t plus yp we find it out earlier sin t. So this is the complete yt solution. Now for particular solution, we need value of constant like c1 and c2. We need value of c1 and c2. So for that we'll use the condition that was given to us, y0 0 is equals to 0, y dash 1 is equals to 1. These are the condition that were given. So we'll put the condition and try to find out the result. So the result So this is y dash 0 is equals to 1. So we'll put the y dash t, we'll find out. We'll put the value of minus 5 c1 sine 5t plus 5 c2 cos 5t plus cos t. We'll put y dash 0 and it should come out to be 1. So minus 5 c2 plus 1 is equals to 1. So come out, c2 will finally come out to be 0. c1 plus 0 is equals to 1. So c1 also 1. This is the result we'll find out. So yt we finally get, it is cos of 5t plus sin t. So this is the final condition that we need to find out. Now we have to make the graphs. For graphs, we'll take, first we'll draw the graph of sin x plus cos x. So this is the graph of sin x. So basically this is a graph of sin t plus cos t. So this is nothing at all, but just we have to make the graph of both the graphs. So here it will be here somewhere. So this is no sine graph, and now we'll make the cos graph on it. So it will basically come out to be this one only. So this is the basic graph of sin t plus cos t. Now we have to make graph of cos 5t plus sin t, cos of 5t plus sin t. First let me make the graph of cos t plus sin t that we find out. So we know the maximum value of cos and sin is 1 1. So maximally they can reach to the value of 2, but one at the maximum, second will not be at the maximum, so it will not reach exactly 2 but somewhere in between. So we'll make the graph like this, not exactly this, and we know as the cos frequency is 5 times, so it will basically more frequency, due to more frequency it will turn out to be this kind of a graph. So this is the kind of graph which will look like to be, and for y is equals to yp graph, it will simply be a sinusoidal graph like this. So this is all at the end of the question number 3. Thank you.